Alrighty, so we're going through all the rules of the logs here. So you notice we are on page 18 to start. Um, we're going to use some notes to kind of help us along these as well. So I'm going to use some area down here to kind of go through them. We know a few of them already, so let's go through the ones we already know. And those are from up above. We know if we are adding two logs together, we could just do log base A of m times n. So we can multiply them together inside. All right. Similarly, if we are subtracting log base A of m divided by n. And 5 and 2 kind of go together. This is the same as log base A of m to the r. So that number is being multiplied in front, it can come up. Or if it's up at the top, well, we'll come back to that one. That one will be a little bit in a second. But that's where we're at right now. Those are the three that we have. And let's go ahead and solve some of these down here. Log base A of 1. Let's just say it's equal to something. I can rewrite this log into exponentials. A to the x equals 1. So it doesn't matter what A is. We're looking for what that x is, right? That's what the equal thing is. Equals. So my x has to be, well, anything to the 0 power is always 1. So x is 0. So the log, if it's log base whatever it is, if it's log base anything of 1, it's always just going to be 0. Similar to thinking like any exponent to the 0 power is 1. Kind of similar idea there. Let's look at the second one. Log base A of A, again, let's set that equal to something x. Well, that would be A to the x equals A. Now, this A does have an exponent of 1, so bases are the same, so that means that x has to equal 1. So the thing this equals is always 1. So when you have the base of the log as the input, it's always just going to be 1. All right, you can kind of think of this as the log is undoing that power. All right. And so this is really where like logs and exponentials, this idea of inverses really comes into play. Let's take a look at it, and then I'll also explain why we say it's like the inverses are important. So we have log base A of A to the m equals x. So normally we could rewrite our logs, right? This is log, the base stays the same, and it would be of that x equals log base A of m. Ooh, that was weird. Since these logs are the same, they basically cancel out, and x would equal m. So the answer here would be m. And so what's really happening here is if it's the same base, they cancel each other out, and you just have the m. All right, this is because exponentials and logs are inverses. It's the same way as thinking if I had like the square root of x squared. My answer would just be x, right? The square root and the square cancel each other out. Or if I had x to the third, I would need to take the third root, right? These numbers need to be the same. Okay? The same way that the log base must be the same as the base, we'll call that a, as a to the whatever that base is. So the bases must need to be the same in order for them to undo it. But when they are the same, they just undo it and you get out m. Now, if you don't remember that, it's okay, because you could just set up this equation and come out with it. All right. And that's what we're going to do here in at 2. I'll show it honestly 3 different ways here. So log base a of a to the r. So I'll stay consistent with what I've done so far. These are parentheses around here. We're going to set that equal to x. Okay, so that means that it's a to the x equals a to the r. So my bases are the same, so x must equal r. Okay, that's one way to do it. Another idea. Log base a of a to the r. That means I have an exponent here. I can bring it out r times log base a of a. Hey, we just figured out that this just equals 1. So it's just r times 1 or r, which again is what we just had. So we're using that property right there. And I guess this is kind of similar, but the other rule is logs are inverses of exponents. So whenever you have the same base, they're going to cancel each other out. This log base a and a is going to cancel out, and my remainder is just r. Whichever way you want to do it, I think this is an okay way, but you have to remember that fact. I like this way because you don't have to remember anything except for the rule of how we switch between logs and exponents. Right? And the last one's not super interesting, but if m equals n, then the log of m equals the log of n. All right? Sometimes comes in handy. All right, but those are your basic properties. All right? So we can use them a little bit here. Just to kind of go through. Use it to find the exact value. It won't be too bad. Basically here, hey, base and the log base are the same. This is just going to be 15. For number 2, hey, I have something out to the 6. I'm going to bring it in front 6 times log base 13 of 13. Hey, look at that. Base, the same. My answer is just 6. I kind of like this one. It's a little combination of 2. Subtractions that we're going to divide. So log base 8 of 16 over 2. That just becomes log base 8 of 8. Oh, look at that. They're the same thing. They're going to cancel out and just be 1. All right. That's all for this video.